is brought to you by the Brainy Couple. So open the description below for more information. So this topic will be on solving of quadratic equation. Solving quadratic equation. So what are quadratic equations? For example, the general equation is ax squared plus bx plus c equals 0. That's a general equation. Okay, so there are a few ways to solve it. One is using this method. Let's see if you remember what method is this. Minus b plus minus b squared minus 4ac divided by 2a. Does this sound familiar? Yeah, this is the method used to find the x of a graph, right? So, but it can also be used for any quadratic equations. Okay, because when you say solve, it means solve for x. Find out what's your x. The second way is this method. Some people call it the old school method. Okay, let's say for example we have this question, which is example is x squared plus 6x plus 8 equals 0. So second way is this old school method. Okay, let's say this question, right? So you put in your x squared here, then you put in the constant. Remember the sign, what's the sign in front? And then you put a 6x, because all is positive, so it's just I didn't put in a plus. So again, what times what give you x squared? X times x. What times what give you 8 is 4 and 2. It can also be 1 and 8. But then I'll try 4 and 2 first. So then I realize that x times 4 you get 4x. X times 2 you get 2x. So this is how I derive that. 4x plus 2x equals to 6x. That means yes, this number is correct. So I'll say, okay, so now I realize x plus 4 times x plus 2 equals 0. So x plus 4 equals 0, or x plus 2 equals 0. So x equals to minus 4, or x equals to minus 2. So here again we have found our numbers for x. If you use this method, you will also be able to find the answer. Just sub in 6 into the b here, 8 into the c, and of course for a is 1. Just substitute in a 1. So of course here we have the so-called the newer method, which I don't really like to use, but one of my students told me about it. It's actually called a frame method, where you have a x squared. Okay, you draw this diagram, and then you have put in the x squared here, and then you put in the constant 8 over here. So how this works is you have to find out what times what gives you this x squared. Okay, the most obvious is x times x. So as you can see, x times x gives you x squared. So again, now is what times what gives you 8? We have 4 and 2. So you also compare. Okay, 4 times 2 gives you 8. So when you use, so what do you fill in for this and this? It is x times 4 gives you 4x. You fill in here. X times 2 you get 2x. You fill in here. So in the end you realize 4x plus 2x equals to 6x. Okay, I'll write down the steps in case people are a bit puzzled. Okay, so first you write out what times what gives you x squared. X times x. Second is you write out what times what gives you 8. So you have to try different numbers. You can try 1 times 8, or you can also try 4 times 2. Don't take note of the sign. Okay, so in the end you have 4x and 2x. That's why we say in the end you realize, oh, my 4x plus 2x give me 6x. So yes, the 4 and 2 is correct. So you end up with this also. You have x plus 4 times x plus 2 equals 0. Okay, so you can solve for your x again. So for the fourth method, it is the completing the square method. Square So again, for the theory of this equation, I will explain in another video, but this video is mainly for those that's doing a quick revision. It's like they have learned a lot of different methods and they don't know what to use. Actually, to solve a quadratic equations, you can use all these 4 methods, any of these 4. But usually I'll use this one first, the second method first, and the first method is because you have to substitute in a lot of numbers. That's why I don't often use it. But for things that cannot be solved using this method, I will straight away use the first one because it's very straightforward and it works for everything. Yeah, it works for everything, every kind of equation. Every kind of quadratic equations, because you will understand what it means by some equations you have fractions in here, right? Yeah, or you have square roots as your part of your x. Okay, so for fourth equation, completing the square method. Sometimes the paper will ask you to solve it using the completing the square method. So for me, I will use the shortcut method for completing the square, which is, okay, let's say you have this question. So what I usually do is I follow this format. The format I memorize is x plus b over 2, the whole thing square, minus b over 2, the whole thing square, equals to 0. So in this question, it will be, okay, I forgot to say, also have to bring down whatever that's constant plus c. Yeah, so this is the equation for completing the square, I call it. And then what you have to do is, okay, let's say for this question, it will be x plus 6 over 2 divided by the whole thing square minus 6 over 2, the whole thing square, plus 8 equals 0. Okay, so do take note, the minus is always a minus here. And for the number here, the plus c, it can be either plus 8 depending on what is here. If it is a minus 8 here, then this will be minus 8. If this is a plus 7, it will be plus 7. So depending on what your c is, it doesn't change. You just bring it down. So then after you solve, plus 3 the whole thing square minus 1 equals 0. So again, you can solve for your s. Remember, when you bring this over and then you square root this thing, so you get plus minus 1. So x equals to, yes, you get the plus minus 1 minus 3. So again, you get your 2 answers. So these are the 4 methods for solving quadratic equations. Are you able to see the bottom one? Okay, I'll push it out higher. There you go, right? So again, you get this. So these are the 4 methods to solve quadratic equations. Now, you may have thought of, there's one more method, which is like the syntactic. You also have to draw something like this. Okay, so the syntactic method, so do take note, the quadratic method is for solving this kind of equations. Ax squared plus bx plus c. But the syntactic method is for solving equations with higher power like x cubed. So for example, okay, I'll write down. You have the solving syntactic equations. So for example, you have one which is 2x cubed minus 5x squared minus 3 minus x plus 3. Okay, let's say the person say, oh, x plus 3 is a can you divide, you have to divide by minus 3. Okay, so the question will usually ask you either to divide by minus 3 or you will say, please find out whether x plus 3 is a factor. Or maybe they will even ask you, please find out what is the factors of this equation. Then what do? Okay, so you do the syntactic equation. So this is the answer, and how it looks is, how the syntactic equation looks is, again you draw an L shape. It looks like the tree diagram. So you have to divide by minus 3, right? Or even if you want to find out whether it's a factor, you also have to use the minus 3 here. So you just write in everything as above as a question. 2 minus 5 minus 1 and plus 3. So what you do first is you bring down these 2 to here. Then you use minus 3 times 2. Okay. Then what do you get? You get minus 6. Okay, so the numbers here we have to add with the numbers here to get numbers below. So here you will get minus 5 plus minus 6, you get minus 11. So now again you use minus 3 times minus 11. You get minus 33, plus 33. Yeah. So plus 33 and minus 1 you have 32. So now you have to use minus 3 times 32, you get minus 96. So minus 96 plus 3, you will get minus 93. So now you realize it looks like a very big number. So this shows that s plus 3 is not a factor. S plus 3 is not a factor. Okay, so s plus 3 is not a factor because this is not equal to 0. Okay, by right this one should be equal to 0, meaning when you use this times this should be equals to 3. So if this one is not a factor, then yeah, because the last number is not 0. So what do you do at the end is what you find out is that your 2x cubed minus 5x squared minus x plus 3, the whole thing when it divides by x plus 3, what you get is actually just 2x squared minus 11x plus 32. You see, you just write in the numbers here. And plus a negative 93 divided by x plus 3. So in the end, yeah, if it is a 0, right, you will get a very nice, if it is a factor, you will get a very nice x squared minus x plus constant. That's it. This should be equal to 0 if it is a constant. But if it is a factor, it should be equal to 0. So do take note, it is x plus, divide by x plus 3, not just divide by negative 3. So what happens, okay, another way to find is the long division method. Long division. So now, what if you want to see, okay, 2x cubed minus 5x squared minus x plus 3 divided by minus 3. How do you find out? Okay, then you have to do the long method, which I did just now, but I lost the video. Okay, so again you do, I should have drawn it so near. Never mind. So minus 3 I put it here, so I have 2x cubed minus 5x squared minus x plus 3. Okay, so when this whole thing divided by minus 3, so I will try to cancel out number by number. Let's say the first number, I will use minus 3 times, it's way too near, minus 3 times minus 2 over 3 x squared. Okay, minus 3 times 2 over 3 x squared, x cubed, then that is what I'll get. I'll get 2x cubed. Okay, so the rest will just continue downwards. Minus x plus 3. Okay, actually I'm not supposed to write that. So I will be left with x squared minus x plus 3. So for the other number, minus 3 times what give me minus 5x squared? Is plus, I'll get minus, it should be a plus 5 over 3 x squared. Then I'll get a minus, so minus 3 times 5 over 3 x squared, I'll get minus 5x squared. And then I continue, why I have space? Never mind. Okay, minus x, minus 3 times what give you minus x? Times 1 over 3 x. Yeah, positive. So I'll get minus x. Okay. I'll get 3, and I just have to plus. Actually, it should be minus 1. Minus 3 times minus 1, I get 3. So I end up with 0. So, okay. Okay. So what do I get? Wait, so if I have a 0 here, why is it that I have a 0 here, but I couldn't get a 0 for above? Okay, never mind. Let me just continue. So, did I make a mistake anywhere? Oh, I didn't. Okay, so yeah, so this is it. So that means after long division, I'll realize that so it's okay for long division. It's natural to get a 0 if you need, because I can actually use any number I want to become a 0. Okay, so I'll equate to minus 2 over 3x cubed plus 5 over 3x squared plus 1 over 3x minus 1. So this is what I get after I use this whole thing divided by minus 3. So this shows that, okay, why do I say that minus 3 is not a factor? Because I'm still left with x cubed and x squared and x. Yeah, that's why it is not a factor. If this is minus 3 is a factor, I'll be only left with x. Maybe I'll be left with x squared and x. I'll get a more simpler number. Okay, so all in all, these are the 4 methods for quadratic equation. The syntactic method for solving powers that's more than 2. Right. Okay, so there's 2 kind of division. One is the syntactic division, another one is a long division. So hopefully you can see a difference between everything that I did here. Okay, so see you next time. Bye. Bye-bye. It's brought to you by the Brainy Couple. So open the description below for more information and a note.